Hello, my name is Alex Gonzalez, and today I'm going to work with arrays. And so probably another type of data structure because of the type of problem that I'm looking at. And I think it might be useful in a way that I am looking into. So the problem is, how do you find duplicates from an unsorted array? So the first method that I've been thinking about is, which is the regular n square complexity that is parsing over two loops the array, right? That's one of the methods and probably the easiest one, but not the best one when there is a large array. So the second method that I thought about, what I've been thinking about, is to create one list, single linked list probably, where I can point to the duplicates and not only point but store their index and use the value as the I don't want to say hash, but as the indicator of what's the list about. So first of all, I need an array, and I'm going to define elements, number of elements. Let's do something easy. Let's do an array of 10 elements, and let's populate it with values, random values. So array I is equal to random mode elements. And I'm going to print the array, and for I equal to 0, I minor elements, I plus plus. I'm gonna do this and then, so I'm just printing right now the array, right? Nothing too fancy. So it's duplicates. My file is named duplicates. So cc duplicates dash show duplicates. Okay. 12. So we have some numbers there, and we can see that some of them are duplicated, such as 3 over here, 6 as well is duplicated, and 5. 2, 9, 1, and 7 are not duplicated. So what I want to do is to create perhaps an array of lists. What I want to do is to create, I can create a list, and then from the list point to the next one, but I want to try to do an array. So struct node I'm gonna do, actually my node is gonna have only the next, the pointer to the next, and index, and the index. In the array. That's gonna be my node. I think that's enough, but I don't want only that. I want multiple lists. Each list is gonna be for each of the values, meaning that 3 is gonna have its list, 6 is gonna have its list, 7, etc. So whenever there is 2 elements, for example, 6 is going to have 2 elements in its own list, and I can even access the array from the list, and that's going to be a quicker way. But before getting there, I want to show you the first method to find the duplicates. Should I? Let me think. Let's do the second way. It's gonna be well. Let's try both. So find or dupes by and 2. Let's do it like that. IN2. For actually for I lower than lms, I'm gonna do the second parsing of a loop for j equal to 0. J lower to lms, k plus, and this is gonna check if I'm gonna say this is one false every time, and I'm gonna define true and false. And what I'm gonna do here is to I'm gonna create better than a counter. This is gonna be initialized to 0. If I equals to j, then the counter plus plus, right? And this is going to be true the first time where I is 0 and j is 0, which means that the counter is it's there. So it's there, so it's going to go to 1. But when j moves to the next one, it's going to be 2. Then means that that is going to compare to the second element, and if the second element is repeated, the counter is going to be plus plus, which means that when we are done here, we can print if counter is greater than 1, means that there are repeated elements, right? So we can print duplicates found, and then we say who. Hold on, this is not here, has to come here because we're comparing, or we're looking for duplicates on I. Let's look. 46. Yeah. Oh no. Okay, so the counter didn't go as I thought. Sorry. So I'm gonna compare. I need to see if the content of the pointers, not the pointer itself. I mean the pointer, the index. So this is probably not necessary anymore, but I'm gonna keep it. Blah blah blah, it's too much. Okay, duplicates found for 3, 6, 5, and then it goes again because it continues to do this. So to fix that, I can create yeah, well, this is something I don't like because I'm gonna consume a lot of memory. But I can create a list yeah, I'm gonna create a pointer to a list. I'm gonna say since the counters were or duplicates were found, I'm gonna add a note. To the list. So to work with lists, I need to first verify if head. Actually, I'm sending the address. Is feed is equal to null because this is the first element added. Then, and I need to send the. Let's sell the value. Array y. So we need to create a node. And then the new node that is already in memory because we are allocating its memory. Next equal to null. A new node. Since this is a simple list, I just need the val. And I'm gonna add the val of the array that was found as duplicated. And I'm gonna use this node as an empty node because this is not going to point to the index or to the index of the array. This is not going to do that. This is going to just store the val. Actually, I don't like that name. I'm gonna use Notepad. Well, doesn't matter. I'm gonna use it just for a little bit. Add them to node. So if it is null, then it's the first element. I'm gonna add the new node. And that's it. But if it's not the first element, we need to send the index to pointer. Sorry for the picture, but they have the keyboard button of print screen too close to the control. It's gonna go to point to the head. So I'm gonna move index to the end. So moving the index to the end of the list. So I'm gonna put it there. And once I am for index next, this is my node. Index next. Not null. But if I am in the first element, then if I am in the second element and there's a list of 2 elements, the last one is gonna be next, pointing to null. And I'm making sure of that here, because the new node that we're creating every time it's on null. So I'm gonna move it to the end. So once I have that, I'm gonna say index next is equal to new node, and that's it. I think so. So the last node of the list, now it's new node. That is an N2. Yeah. So okay. I think that's it for when I'm adding. I'm gonna test it in a second, but I'm adding to the node. So add into node. So hold on, I'm thinking. If a duplicate is found, then go here. Now. if val not parsed, if this is not already parsed, I mean this I, then say duplicates found and add it to the node. Now, how do we know if the val is not parsed? By looking into the list that we created. Now, let's do it right through the list. And I'm gonna send the list without the address because I'm not gonna change anything. I'm just gonna verify if the value already exists there. Why am I not using an array? Because I might need, if it is a 100 elements array, I'm gonna need another 100 elements array at least to make sure that I have a space for all the values, and I can play with the index and the value, but that's going to consume a lot of memory, and that's probably not necessary. I don't think it's necessary. So that's why I'm trying to use a list to. It's for this use case, it's less expensive than having a 100 elements array, especially when there is a 1,000 elements array or more, right? If this is only a 10 elements array, then it's not probably worth having a list, but for me it makes more sense. So int val and struct and2, I'm getting the head here. So for, I'm going to say index here, straight. The index is going to the head. Oh, yeah, that's fine. I was thinking that probably the head had to be updated over here, but since this is a single linked list, I don't need to update the head here. There's no reason because I'm adding at the end of the list, and that's fine. Okay, so what I'm gonna do is to parse the list. For index not equal to null, this is going to assure that I'm going to count even the last element of the list. Index equals to index subfield next. And here I'm going to say if the val is equal to val, then to turn true. Well, I'm going to say val parsed. Val parsed means that it's already return true. We already have true defined. Else return false. So if not parsed, then say duplicates found and add it. If already parsed, then don't do and don't say anything and don't add anything. That's fine. We are not storing any number of elements that are there. So, I mean, we're not storing the indexes of the array where the duplicates are found, and that's why I want to use a different method, because that's kind of more interesting and more fun, has its challenge, and probably is even more useful at some point. So I think that's it, except that let's see. Few errors, 37, struct node, size of. Struct, and two node. No. Unite, okay. Incompatible pointer, okay. Come on. Index next. Index next. Sign in for a compatible pointer. Strip node. I'm returning this. Okay, you have a segmentation fault. 3 seems that it was found, which means that the first element was found, was passed, and then actually we printed, and then we went to segmentation fault. Let's see. I'm not doing any free of the memory, but that's fine for these purposes and this short item. Seems like probably I'm getting lost here. I'm not validating that this exists. Added second, but it never was at first. So I'm pointing to a null. Okay. Meaning here, I'm gonna print the head it's pointing to an invalid memory address, which means that it's coming 30, and that's because this is not initialized. Okay, so we are not having a segmentation fault anymore, but at the same time, well, parsed is not telling us much, but apparently I don't have this validation, because it's coming null, it's never gonna come here and never gonna pretty much return anything. Maybe. Let's see. Go. Invalid operands to binary equal. I have okay. Struct node and void test. Okay. I'm just gonna cast the pointer. Okay. Duplicates found 3. Added the first one. Duplicates found for 6. Added the second one in a valid address. Duplicates found for 5. And then we have 3, 5, and then 6. So we're getting there, but it's not yet perfect. So I'm not gonna need this anymore. So the 3 is working, not the 6 and the 5s, which is something that I have to fix now. But this is not moving. But it is moving because it finishes. Yeah. Okay, so yeah, it was totally a misunderstanding of myself doing or returning some value immediately, and I was never really parsing everything. I was just returning a value. So yeah, this was the problem. Phew. Took me a while. So yeah, duplicates found for 3, 5, and 6 as expected. And yeah. So I'm gonna divide this video because what I want to do next with this problem, what I wanted to do next is to also save the indexes of those, but I'm gonna skip that since this took me a while, and I'm not going to do it in this video. I'm going to do it in a different video. Starting from this code. All right. Cheers. Thank you.